prepare for doing a statistics project in this class, and so to do that we have to learn about different types of studies that you can perform, and we're also going to take a look at bias today. So first we're going to talk about the different types of studies in experimental design, and there's three that we're going to focus on. So here's the first example. Rebecca and Tova have math class right after lunch. Rebecca always eats a hot lunch on days when she has an exam because she has this theory that people score a little higher on math exams when they have eaten a hot meal. Tova is very skeptical of this theory. How can Rebecca and Tova test whether the theory is valid? So Rebecca and Tova write down as many of their own exam scores as they can remember, and they record whether they had a cold lunch or a hot lunch on the days of those exams. They ask a few of their friends to give them the same information, and they find the average of all the scores associated with the cold lunch and all the scores associated with the hot lunch. A few questions. Do you feel Tova and Rebecca's method of data collection will give them valid conclusions about Rebecca's theory? Explain. And how could they have improved their method to get more unbiased results? So in class, we kind of talk about how if you only look at two people's results, it's probably not valid. You'd have to poll a lot of different people. And when you do that, do people really remember if they had hot lunch or cold lunch and all the different scores? So when you design a study, you want to design something that eliminates any bias, like people's memories and stuff like that that could affect the study. There are three ways that we're going to talk about to collect data, and they are experimental, observational, and a survey. So in an experimental study, treatments or assignments are applied to subjects as assigned by the researcher. So here's an example. A number of students agree to help. The students, which are the subjects, are randomly assigned to one of two groups. On the day of exam, the exam, group 1 eats hot lunch, group 2 eats cold lunch, and then they record the results. So there's an experiment. You're kind of designing it. You're assigning what's going to happen to each person or each thing, and then you record the results. In an observational study, you don't assign things. So treatments are not applied by the researcher. Subjects know they are being observed, but they don't know what is being observed. So an example, a number of subjects are observed at lunch, and the researchers collect, did they eat hot lunch or did they eat cold lunch? And then they record the results from there. So the people don't know why they're being observed. And the last type of study we're going to look at is a survey. Information about treatments and or results is collected. So for example, you could give a questionnaire to members of the class asking what kind of lunch they had and then also what their test scores were. So these are the three that we're going to look at, and for your stats project you're going to pick one of these to work on. All right, so here's the experimental study. So you assign the groups, you assign the treatment, and then you look at the responses. Let's evaluate each of these statistics. Arthur says that 71.43% of the students hate the new school dress code. He interviewed 7 people in the parking lot after school and asked them, do you like the way the school is forcing us to dress? So first of all, what kind of study is this? Is it an experiment, an observation, or a survey? And so this would be a survey. He's interviewing 7 people. And the next question would be, is there any bias in this? And you could say, well, the way he asked the question, do you like the way the school is forcing us to dress? That kind of throws bias or kind of shows his opinion and might influence the answers of his subjects. Situation 2. Betty claims that the typical student spends $19.93 on fast food every month. She passes out a survey to 30 students in her algebra class, and 20 of the surveys were returned. The survey question read, how much did you spend last week at fast food restaurants? So this would be a survey, and there doesn't seem to be much bias in it, although she only asked 30 students in her algebra class. So there might be bias because of just the low number of students asked, and also that they were just in one of her classes, in her algebra class. So that also would influence her results. Situation 3. Carl states that the number of students in multiple suspensions has increased by 67% in the last 10 years. He found out from school records that last year there were only 5 students with multiple suspensions, and 11 years ago there were only 3. So what kind of study is this? This would be an observation. So he's going back and observing what happened. And is there any bias or misrepresentation in this study? And there would be, because 67% is a huge increase. But if we look at the actual numbers, 5 students versus 3 students, isn't really that huge of a jump. You'd also have to look at what was the increase in the student population. So here there's some misrepresentation. So there's 2 words here, bias and misrepresentation, that we're going to watch a video about. So from this part of the presentation, you should know the 3 types of studies: experiment, an observation, or a survey. And now we're going to watch a video on What is misrepresentation and bias in a study? So we're going to watch this video.
Each and every day, the media fills our heads with numbers. The economy, crime rates, test scores, poll results, and medical studies. It's nearly impossible to get through the day without hearing numbers in the news. When it's not numbers that we're hearing, it's often the results of statistical studies that newscasters and TV show hosts are discussing. Some of the headlines are so poorly thought out that they're funny, while others, those are scary. H.G. Wells once said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Well, boys and girls, one day is here. The hardest part of statistics is collecting data. Poorly collected data can produce misleading results. Consider the publishing company that is trying to get an idea for a new magazine that will appeal to a certain community. Using their knowledge of elementary statistics, they come up with a simple random sample of residences in that area and call the homes during regular business hours, asking about their favorite magazine. The results? Overwhelmingly, the majority of respondents answered Parenting Magazine or House and Garden. The problem? They called during business hours when most people are at work. Stay-at-home moms are most likely to answer the phone during these hours. This sample is not representative of the population of interest, and the results are therefore inconclusive. The publishing company has wasted valuable time and money. Even when appropriate sampling techniques are employed, the questions posed need to be carefully worded not to elicit biased responses. A sample of people were posed the question, researchers at a leading university claim that electromagnetic fields produced by devices like cell phones may cause cancer and other neurological diseases. Do you agree? The vast majority of people in this sample responded with yes. Do you think that the results might differ if the researchers had simply asked, do you think cell phones cause cancer? Certainly. If a leading researcher says it's true, people are likely to agree with that result. Most of us certainly don't know enough about electromagnetic fields to draw a conclusion on our own. Who's going to disagree with professors at a leading university anyway? If that's not convincing enough, allow me to lend an example from my own life. When I was in 4th grade, if someone would have asked me, do you believe in Santa? I would have answered, yes. But when my mom casually asked, Emily, you don't still believe in Santa, do you? Not only did she basically tell me Santa wasn't real, I felt as though I had to answer no. Sometimes bad statistics are produced by the numbers themselves, rather than the collection methods. Careful exploratory data analysis must be done in order to choose appropriate ways to report summarized data. Consider the following true statistic. The average starting salary of geography majors graduating from the University of North Carolina in 1986 was $250,000. Why are UNC geography grads making so much money when nationally graduates in geography are starting at $22,000 a year? Michael Jordan earned his geography degree this year and went on to make over $700,000 in the NBA. You see, the average is computed by taking the sum of the data values and dividing that sum by the number of data values. This measure of center is highly affected by outliers, an individual value that falls outside of the overall pattern of the data. While the average is accurately reported, the statisticians should have used the median or the middle value to report the average starting salary based on the presence of extreme values. Technically, the information gathered in these examples are accurate. They're just misleading to someone who reads the reports and is unaware of the methods used for gathering or analyzing data. Be a skeptic and be educated so that you aren't a victim of bad statistics.
So this kind of just gives you ideas of how you can look at bias and misrepresentation, try to take them out of your project. So in class we're going to review these and we're going to talk about how you can do your project.